Good morning, students. So let's quickly start with the today's lecture. Today we will discuss the bandwidth utilization. So before moving on to the topic, let's first discuss what is a bandwidth. So sometimes we mix it with the speed of the internet, but that is not the part. The speed of internet depends upon the package you have taken from the your internet service provider. That may be very much differentiate from the bandwidth as well as from the internet speed. So there is huge difference between it sometimes, but not all the time. So the bandwidth is maximum amount of data transmitted over an internet connection in a given amount of time. That is called the bandwidth. So that means you now suppose your link is porting. To understand this, now suppose this is system and this is the internet service provider, and there is a link between them. So this is the link between them. That link will support 100 Mbps. Okay, that will support 100 Mbps. Means 100 megabytes per second, but you have taken the package of 10 Mbps. Okay. So your speed will not exceed this 10 Mbps, but your actual connection will handle the 100 Mbps. So that is called as the bandwidth of your channel. Okay. So the maximum amount of data transmitted over the internet is in a connection of a given connection. You see connection in a given amount of time. So the time is here, second, and data means amount of data means Mbps. Okay, MB. So megabytes per second. So you have taken the package of this 10 Mbps. Okay, so this is your internet speed, maximum internet speed, but the maximum data transfer that your connection can handle is 100 Mbps. So this is the bandwidth of your connection. Clear with this? So it is often that I have already told that it is mistaken for internet speed when it's actually volume of information that can be sent over a connection in a measured amount of time. So calculated mostly in megabytes per second nowadays. In the earlier days, it was in kbps, but now due to the advancements in the internet technology as well as in the computer technology, the data transferred now is in the speed of Mbps. Clear? So bandwidth utilization. So see, we are our connection is supporting the 100 Mbps data, but we are actually using the maximum 10 Mbps. So maximum means at very peak time we can use only the 10% of our connection. So that is not the proper utilization of the bandwidth of your connection. So bandwidth utilization is the use of available bandwidth to achieve the specific goals. So that means to use the remaining 90% of our connection speed, that is called as the bandwidth utilization. So with this, efficiency can be achieved by multiplexing, privacy, and anti-jamming can be achieved by using the spreading. So efficiency can be improved by multiplexing the data. Multiplexing means many to one, means many signals will come over a single channel. So multiplexing is a set of techniques that allow the simultaneous transmission of multiple signals across a single data link. So multiplexing could be like, suppose this is the multiplexer, number of signals are coming from it. Multiple signals are coming to it. Okay. And only the single, all these signals will be going to the single channel. Means these signals will be clubbed over here and transmitted over this channel. Clear? Whenever the bandwidth of a medium linking two devices is greater than the bandwidth needs of the devices, the link can be shared. Now suppose you are using the 10 Mbps data out of 100 Mbps. So that means your link can be shared with the other set of works. So multiplexing we have already discussed. So data and telecommunication use increases, so does traffic. So as we increases the utilization of internet or telecommunication resources, the traffic also increases. That will lead to the jamming or loss of data. So dividing a link into channels. So these are the multiple links that are coming, multiple inputs that are coming to the multiplexer are now this is the single link. So that link will have multiple channels of different speed, and these data will be transferred over here. It is not clubbed together, but on a single link, multiple channels will be created to which the data is being shared. Clear? And similarly, at the demux, that channels will be differentiated, and to the different output lines, that data will be transmitted. So categories of multiplexing are, these are FDM, WDM, and TDM. So FDM and WDM are frequency division multiplexing and wavelength division multiplexing, whereas the digital form is time division multiplexing. The first two, frequency and wavelength, are analog. Means their signal will go like this in the round form. But in time division we have in the digital form like this. So frequency division multiplexing is, this is the rough figure of this FDM. Input lines are coming to the mux, and mux will create the number of channels over a single link, and then it will reach the demux, and output lines are created according to the channel. So FDM is analog multiplexing technique that combines the analog signals only, and it is uses the concept of modulation. So this is the process of this FDM. Modulator will modify the signals. Suppose this is the input signals, uh, or baseband analog signal is this, and this carrier F1, F2, and F3 is used to create the channels over here. So it will create the signals like this bar, and see this bar is like this, and it is creating the signals to this form. Okay, so similarly here the another modulator is used to create this wave into the sine waves like this, and similarly at the third point we have like this, and combinedly it is it is in this format that will be transmitted over the link. So at the receiver's end, it is coming to the demux, and filters are being implemented, and it is filtered between these three types, and the user at the receiver side will be able to receive the signals. Okay, so we are doing this on the basis of frequencies, on different frequencies that are being transmitted to the other end. Similarly, now suppose if we have a question that if same signal at the same frequency will be given over here, then the one signal will be in wait state, whereas the process once the uh, signals that is whose process is ongoing will be processed. Till that time the another signal will be in the wait state. Okay, clear with this? That for same frequency, we will use the wait state. Next is the wavelength division multiplexing. Now signals can be transmitted in the type of frequency, wavelength, or time division. So these are the wavelength division multiplexing. The task is same over here, that analog multiplexing technique is used to combine the signals, and these are the wavelengths that are being multiplexed from by using the prism to the uh, signal, and they are being transferred, and at the receiver's end the demultiplexer will differentiate the different wavelengths to their different output lines. Exit time division multiplexing. So it is a technique for combining several low rate detail channels into the one higher rate. So similarly, like 1, 2, 3, and 4. So first of all, this data will be transferred, then second, then third over a single link, and data flow will be like this in from mux to dmux. So mux will be at the sender side, whereas dmux will be at the receiver side. And in this is a digital multiplexing technique, means 0 and 1s will be used in it. So this is not the data that is 1, 2, 3, 4. Basically, the first system is you can say that these are the priorities given to the systems. And first of all, the first system will send the data. After that, second, then after time interval, third, and then fourth. Similarly, at the second point, then again, first will send, second, third, and fourth. Okay, clear? Okay, so this is the synchronous time division multiplexing, in which the data is shared like this. So suppose these are the frames that are being at the center of the multiplexer. So first of all, like A1 will send that data, then B will send its first frame, then C1. After that, A2 will send frame B2 and C2. Now suppose if there is a different data between A1, B1, A, B, and C. So now suppose at this point A4 is there and C4 is there, but no B4 is there. So at this point, the A4, only the A4 and B4, A4 and C4 will be transmit their data, because B1 has finished its transmission of data. So data rate of the link is in n times faster, and the unit duration is n times shorter. Means as soon as the data rate is faster, the duration of transmitting the data will be shorter. So they are inversely proportional to each other. If the speed is low, the duration is high. If the speed is fast, the duration will be low. So next is the time slot duration. In this case, at the time slot duration, if we do not have the data, we have to implement the empty time slot over here. Like this is the 0 frame, this is the first frame, and A1 is transferred. Now here we have data is A1, B1, and D1. So A1 will be there, B1 will be there, C1 is not there, so its time slot will be empty. Similarly for E1, it is empty. At second point, A1, A2 will be empty, B2 is there, C2 will be empty, and D2 and E2 is there. Okay. So for statistical TDM, the empty slots will not be implemented and only the actual data will be transmitted from sender to the receiver. Okay, clear? So this is the topic of your lecture.